Okay, welcome to Swell Academy. Today we're going over some practice examples that are dealing with distance, midpoint, and of a number line, and kind of maybe some algebra. So first we look at a question. Usually we're used to getting a number line in which they give us the 2 and the 10 maybe, and they're asking for the midpoint, in this case 6. Here they're giving us the midpoint. So I like to start off by kind of presenting that midpoint formula, MP for midpoint, and maybe just looking at it from the perspective, okay, let me just fill in what I have. I don't have the 1 point, I have the first one. Divide that by 2 and that's gonna give me a midpoint of 8. If I'm able to set up this formula, I could really manage any type of question and any type of number. 2 plus x is equal to 16, subtract 2, x is equal to 14. And that would be my answer for what this point needs to be. And if I were to plug the 2 and the 14 into this equation here, I would in fact get the 8. You could also identify that the distance from here to here is 6. So maybe the distance from here to here, you want to be 6 as well. But if you're presented with fractions and decimals, that could get a little difficult. Here's a good question because, okay, again, we're used to seeing a midpoint maybe 2 and 8, like we just showed. 2 plus 8 over 2, easy enough. 10 divided by 2, my midpoint is 5. But what about if I'm presented with some fractions? So I just want to show you how you're going to take yourself through that process. Again, get your midpoint formula down, fill in that midpoint formula, but you might want to start by 3 times 4 plus 1, making an improper fraction of negative 13 over 3. And doing the same for this and changing this to a 13 over 2. And then dividing all that by 2. Like denominator is gonna bring us to 2 fractions that are over 6. 3 times 2 is 6, so negative 13 times 2 is negative 26. 2 times 3 is 6, so 13 times 3 is 39, and that is also over 2. I would focus on working with the numerator first. That's kind of like a standard rule when working with fractions. And that brings me to a value of positive 13 over 6 divided by 2. Now, mind you that this is this fraction divided by 2. I can write it like that. So maybe I want to write it like 13 over 6 divided by 2, which I could say is 2 over 1. And then when you divide a fraction by another fraction, you're going to multiply it by its reciprocal. So I've flipped this fraction, there's a flip involved there, and then multiplied. And when you multiply fractions, you're multiplying across 13 over 12. The numerator is bigger than the denominator, so I'm going to want to say 12 goes into 13 once with 1 left over. And the answer of my midpoint to these two points here would be 1 and 1/12. So that's just kind of a midpoint example with fractions. I like this because it doesn't give you a diagram, and in this case, these 3 points on the line and M being a midpoint is something like I've said in geometry where you're going to want to draw and get a visual of that. P, M, and Q. And when they say respectively and they're saying P and M, they're basically saying in order. So negative 2.5 and 2.2 here. Now there are 2 ways to solve this. I'm going to show you the one that I like and prefer. Basically, I'm just going to want to find what is the distance from P to M. And once I find that, I could just add to M and find this Q. Now our distance formula we've gone over is A minus B. It's the absolute value of the difference of the 2 points. So we have negative 2.5 minus 2.2 absolute value, negative 4.7 absolute value. So my distance from P to M is is 4.7. So if I want to go to M to Q, I just simply need to add the 4.7 and get 6.9. And that would be my coordinate location for Q. You can use, as we did in the other question, your midpoint formula here and set it equal to your midpoint, right? We have the 1 point, not the other, divided by 2, and we end up with our midpoint. Multiply both sides by 2, and now we begin to isolate, running out of that color, begin to isolate our unknown B, 4.4, add 2.5 to both sides, and you end up with B is equal to 6.9. And that's the same result we worked with. So I wanted to show you either way of solving this question. I like this question here because this actually offers quite a few parts of a diagram to draw. M being the midpoint of PQ, that's a good start. N being the midpoint of MQ, and L being the midpoint of MN. And the first numeric piece of information they give us is that MN is 12. Now, before I answer the question, I basically want to go ahead and fill out all these other pieces. And if I'm dealing with midpoints, I'm dealing with halves, basically, right? So if this is 12, then both of these are 6. And if MN is half of MQ, then NQ would also be 12, right? If MN is 12, that's halfway. And then add those together, this is 24. And if this is 24 and M is halfway between PQ, then this would here also be 24. And although they ask me what ML is, and in this case 6, any set of coordinates they give me, maybe LQ, which is 18, PN, which is 36, any 2 letters they give me to solve for the distance, I'm able to do using my kind of already filled out segment addition here, my segments. This is a good question because it involves finding a distance and then going a fraction amount of the way from 1 point. So if I'm working with that, the first thing I want to establish is what is the distance from here to here. And in order to do that, I have to use my distance formula. And in this case, again, I want to go to improper fraction. 5 times 3 plus 2 is negative 17 over 5, minus 5 times 7 plus 3, 38 over 5. And I have like denominators, so no change there. I'm subtracting from another negative, so I'm adding negatives. I end up with a negative 55 over 5, a negative 11, or 11 here. So my distance from here to here is 11. Now, if I want to go 4/5 of the way, basically I want to start at this negative 3 2/5 point, and I want to go 4/5 of the way to another coordinate before I get to 7 3/5. If this were all a number line here. So basically all I'm going to do, like I did in the other question, I'm going to use that initial point of negative 17 over 5, which is this here, and I'm going to add 4/5 of the way. So if I know the way is 11, right, a distance 11, I want to go 4/5 of that. Then I want to go 44/5 of that total 11 here. So what I'm going to do is add that 44/5 to the 17. If you have different numbers, find the difference, which is 27, and take the sign of the bigger number here, which is positive. So I get 27 over 5. 5 goes into 27 5 times, right? If I were dividing 27 by 5, it would go in 5 times with 2 left over. So I get 5 2/5. And basically, this is the point, 5 2/5. That is 4/5 of the way. Couple steps here. There is fractions, there is absolute value, but again, we're relying on our distance and midpoint formulas. Hope this helps.